Let's make the design of the screw-retained crown and abutment in one case. We'll open lab order form, customer, patient, number of lab order form, technician. Commands. We place adjacent tooth, antagonist, so everything as we've done before in other cases that we've seen previously. 2.4 would be abutment, but if we were doing abutment, we have to fill it in like anatomic crown, so we choose anatomic crown material, for example, zirconia. Type of implant. Here we can divide it into groups. First group, where you see in the brackets manual positioning, it means scanning of the tie base. The advantage, they can take any tie base from any manufacturer and make the scanning, coating with a very thin layer of the spray. Disadvantage, very low quality of scanning and not very good marginal fit. But the advantage, you can take it from any manufacturer. Where you don't see brackets, you see custom abutment and screw retention. It means that to make the scanning with the scan abutments. Advantage, very high accuracy, but disadvantage, you have to have for any system scan abutments. Right now we'll do the work with the help of the scan abutments. The accuracy and precision would be better. In other cases, I'll show you how to make the design of the restoration with the tie bases without scanning of scan abutments. So we'll have 2.4 full anatomy, anatomic crown, and we choose anatomic custom abutment without brackets, line without brackets. Here we can choose the material that we use for milling. Right now it's not important. What does mean scan a pre-op model? It means in situ scan. You have a work-up or we have impression before the preparation. We can put here yes, and we'll have additional step of this scanning, additional scanning of something. Right now we don't have it. Scan of the gingiva. If we have silicon mask that is removable on the plaster models, and usually it's removable if you work on creation of the abutment, so we type here yes. So we have additional step of the scanning. We additionally have to do the scan of the silicon mask, so of the gingiva. Then it's standard and we press OK. Tooth number 2, 6. We have the same anatomic crown, material zirconia, but the type of implant we choose not custom abutment, we choose screw retained. Also the line without brackets. And we press OK. We already have scan of the gingiva. Type of antagonist, we choose two-stone models in occlusion, save, scanning, design. So here is our case. What do we have here? These are scan abutments or scan markers. Scan of the gingiva. In this situation, we placed zircon-zan scan abutments. So each scan abutment has its own geometry. It's very important during the scanning to place it very tightly without gingiva mask, so not to have any interference in the sitting of the scan abutments. Then in the first step, the program proposed to us to choose this system. So we click on the list and we can choose the system of scan abutments, then the manufacturer. Right now it's zircon-zan. You have to have the list of the acronyms of the scan abutments that you've bought, just to understand where it is from. For example, zircon-zan ABUTMENT. It's certain type of scan abutments, and each scan abutment has its own name. As soon as it make the choice of scan abutments, for example for Nobel, we choose the diameter. For example 4.5. Next step, we are choosing the type of the titanium base. It could be parallel for single crowns, for example, or if it would be a bridge with a screw retention, it would be conical. We have to choose conical for bridges. Dependent from the type of implants from the company that produces scan abutments, you'll have possibility to choose some other elements here in this field. For example, we can use milled hex. Right now we don't have it in this list. It depends what kind of scan abutment you purchased. Also, you can load the library from the website of the manufacturer and put it in a folder library in Dental Cut, in ExaCut, and you'll have it in the list here. But I'll show this information on our last case where we talk about tips and tricks. As soon as we made the choice of the company, manufacturer, diameter, the type of the base, it is important that the scan abutment that you have physically would be coincident with what you have here on these graphics. Also, we can check and you can compare. So we have the position of the scan abutment, scan marker. Right now we have to place the dot as it's shown on the screen in the upper part of the triangle. We click one time. So first it makes a rough matching when we press best fit matching. So our virtual scan abutments and real scan abutments are in the same position. So and a position of the implant in the bone here virtually without any arrows, without any description. So when you do scanning from thermoplaster model, you can remove silicone mask, you can remove adjacent tooth and make the scanning of the whole scan abutment. When you do scanning with the intraoral scanner in the oral cavity, the geometry of scan abutments is different. It's more narrow just to be able to fit in the dental arch, but there are a slight difference when you place scan abutment in the soft tissue, so it will be covered by the gingiva. So we try to superimpose scan abutments on this first step. It's very important to raise this bar. So we have to cut the excess, what is subgingivally, what we don't see, and to leave the upper part of the geometry. So the program would use only the upper part of the scan abutments for the superimposition. In that case, superimposition would be more precise. Many people don't know about that, so they don't raise this bar, and they trying to superimpose these scan abutment, but will be an arrow because it tries to analyze the whole surface, but the lower part would already be distorted, so it would interfere in a precise superimposition. So we raise the bar and we do best fit matching. Next, when they do scanning from the plaster model, it's not required, but when you do intraoral scanning, you have to do it anyway. When you did the superimposition, you make superimposition of the point, you make best fit matching. So we press next, we go to the next tooth. Here is the same system, the same diameter, we don't change anything. Also, we place the dot, we have to raise the bar a little bit, place the dot, make best fit matching, next. Step number 2. We have to define the emergence profile. So, the gingival line, the borders where the abutment would be situated. Before the scanning, of course, we have to try to adjust the soft tissues, but if you forgot to do it or it was impossible, so you can correct the gingiva virtually. We go to the expert mode, we click on the soft tissue with the right mouse button, and we choose freeform scan data, correction of the scan. Right now, I can create any form I need with the help of the Ctrl Shift or Shift. And we press OK. I like it. I'll go to the wizard mode again, and we keep on working here. Because tooth number 24 is abutment, so we have to do the subgingival area. So we place 4 dots, 1, 2, 3, 4, and the program gives me a very rough line that we have to adjust. So this is a finish line of the abutment. We press correct, draw, with the left mouse button we can lower it, so I'll make the deepening about 0.5, 0.7 millimeters subgingivally. Very often customers ask us to leave from the palatal side the finish line at the level of the gingiva, so not to place it too subgingivally. So during the cementation it will be easier to remove the excess of the material. Sometimes I do for anterior teeth lowering 0.7 buccally, 0.3 proximally and 0 on the palatal side. If we need to measure to see how much did I put a line subgingivally, I can do it with several options. First is measuring tool. Go to the tools, distances, ruler, small window. We put in 2 dots, point A, point B, so we can measure the distance. Clear. Also point A, point B. There is one trick. If we placed 0.7 subgingivally, we measured with a ruler, but the milled finish line of the abutment will be a little bit higher. So if you want really to see the subgingival location of the finish line on 0.5, so virtually you have to lower it 1 millimeter, because 0.5 would be this kind of arrow of this width of the finish line. So if you want to get exact result, you have to know that. One more thing, on abutment I'm drawing the finish line. You see, when press next, we're going to the screw retained crown. Here I'm not placing points, I'm not drawing this edging, and you'll understand later why. We just skip this step. We go to the step mirroring. I'm not going to do a mirror image of anything, so we'll skip it, and we go into the setup. In any case, if we are doing the framework, the full anatomy abutment, we are starting from the tooth placement with the setup. So we have to understand how the final restoration would look like. So the placement step is very important even for abutments. We have correctly integrate the premolar with antagonist, because it will be our future reference. Here we have the full anatomy from the shaft. The placement is finished, so we press next. After the setup, we go to the step how to make the gingival part of the abutment. I removed everything I don't need just to see the finish line and the so-called chalice of the abutment. We see on which line, on which height is the finish line of the abutment. We can do with the shift and wheel semi-transparent view of the abutment, or here with the navigation. In the beginning we made the drawing of the finish line. Right now here we can correct it. If I hold the left mouse button and I will move up and down, it is attached to the gingiva. As long as it's pink color, it's attached to the gingiva. No matter how I would move it down, it will change along the gingiva, changing its form. If you want to release it from the gingiva, just to have a free form, when we click with the left mouse button on this disc, and then this finish line is not attached to the gingiva. As long as we press again, it will be attached to the gingiva again. With the help of Ctrl and left mouse button, we can attach everything together and release everything at the same time. With the clicking of the left mouse button, Ctrl and left mouse button, we can remove it and switch it on again. Don't forget to use hotkeys. The list of hotkeys you can see in the internet if you just type Exact Wikipedia. With the Ctrl and left mouse button, we can create new dots. If I put the cursor and press left and then right, we can remove Ctrl left mouse button, it appears. Left and right mouse button, it will be disappearing. That's what about finish line. Then it's very important to make the form of this chalice, of this subgingival area. The program proposed this form, but the gingiva is wider. So we have to decide whether you want to create a compression or to have this kind of subgingival form of this chalice. Just to change the form, we have two scrolls here, scroll lines, which we can move, or we can place tick in the box free form with the left mouse button, and with clicks we can create pressure in certain areas. With a shift I can remove or add. So deliberately the program adds with big areas, not like during the design of the tooth. It is done just not to create undercuts in this zone. So how can we see what kind of compression we created? We can do it just judging by the eyesight, making the semi-transparent appearance of this chalice, but it's not very informative. We'll go to the tools, we'll go to the sectional view. In a small window we are moving this scroll forward, and we do have these cuts. And in these cuts also we go to the tools, measuring tool, and we can place two dots, point A, point B. If I would add with clicks, we can measure again. Also, we have function not only the having the slices, the cut, but also cut view. I will click here and I can just easily move this plate with the mouse. I can click to fix its position, I can increase its view, zoom in, and just to measure it in this window. Which way to use, you can decide yourself. These are major, really useful functions. We press next and we go into the step of additional design, as we call it, because in one case we have screw retain crown and abutment. On this step we need to create full anatomy for the screw retention at least, because for abutment it's enough the form that we have initially as a reference. It will be more than enough. But right now I want to show you the trick of this line that we placed for abutment, and we didn't draw it for the screw retain crown. We have this form of the chalice, some gingival part, which is not movable. No matter how I try to design it, it's not reacting. And this transition edge, transition line, we have to smooth it. So we have full anatomy, we'll have this edging, and we have to try to smoothen it after the milling. That's why I didn't put points. So here I can make the design of the form I need. So the emergence profile that I think is correct here. For that we increase the size of the brush, and with a shift we can try to round it. If we choose smooth and shift, it will be doing it much faster. In any case, I'm making the design with pressure, I'm making the correct form. Then we choose, for example, add, remove, and we also correcting it. We switch off the gingiva from the screen with the Control and wheel, and we can do additional modeling. So here it is. We press cut all intersections. We use all the knowledge that we accumulated from previous cases. Everything is the same. And we press next. As soon as we've finished forming of the full anatomy, we can forget about this tooth. Right now we have the last step, the shaft screw access hole that the program will do itself. And right now we're going back to abutment. Right now the program proposes to us to manually define the angulation of the abutment. It's not the shaft but the abutment. So the way we want it would be situated into the arch, not the shaft but abutment. In some scan abutments you can change it, but not here. So if we have on this stage, we'll have not one but 3 abutments where we want to make one bridge. We have to create these abutments with the same inclination. So we click here in this window on the teeth. We want to have the exact inclination. So we'll do the changes of inclination of one abutment, and there'll be changes for all abutments. We go into the stage of the forming of the abutment design. So program proposes a certain form. We can switch on here the mode of the full anatomy as a reference. Well, it seems like we have to make the design of the prepped tooth. It looks like it. So what kind of buttons we have for the manipulation? With the help of left mouse button and the wheel, with the control and the wheel, we create new dots. With the left mouse button and right mouse button, we remove these dots. Once again, control, left mouse button, we create dots. Left and right mouse button, we remove these dots. If we hold with the left mouse button on the upper part, I will raise it in height. If I hold it from the side, we can change the inclination of the walls and may expand them. Lower part, we can make the displacement according to the gingival line. Also, we go back internally, externally. You need practice, you'll get used to it. So we can displace, you can raise, you can decrease. With control left, we create new dot, and for example, we lower it on the finish line. So that's how we make the displacement, and we can regulate the angles of the abutment walls. We can move all together if we hold control and left mouse button, and we can make widening and narrowing. Here you see the block 2 degrees. So more than 2 degrees, you couldn't make the expansion. No matter how you try it, you can place 0 or 4 degrees, but I'm working with the setting 2 degrees. It's one parameter that we need. Then I can hold with the control left mouse button and can make the finish line wider and more even on 360 degrees. We create several dots at the same time, and we can move it inside here, this area, creating this anti-rotational element. We can do it during the function attachment, but I like this opportunity because it creates more smooth lines. We switch on full anatomy, and we can take a look where we are according to the full anatomy. Always try to look at the design from different angles. The walls has to be aligned with without big inclinations. So let's look how it will be situated in the arch and according to the antagonist. If you take notice, you see that there is slight interference here. We can remove it like that. I repeat, control left mouse button, and we displace it internally like that. Very easy. Let's assume that on this stage we understood that on the gingival area we did a mistake, so we want to adjust it. So we're going to the function bottom. We go into the step of the correction where you can move, displace, widen and narrowing this finish line. Then we press again abutment, and we are working again with abutment design. Also, there are more possibilities to change the geometry of the finish line and angles of abutment. I'm not trying to interfere here. This form is okay for me because it will be very good for getting rid of the cement flush. But I'll do a small cut here, and I press next. We go into the step of additional correction of the abutment. Here we can remove part from to make it not so high, so to create more space for antagonist. And you don't need to smooth the walls, otherwise we'll lose this axial inclination. So some artifacts are present, but here we can remove them if we just will move to the left and right this line. But I don't like try to do the maximum design in program, but some things we can adjust after the milling, for example. But try to do as maximum as possible in the program during the design steps. And we press next, we go into the finishing step. If we want, we press next. If we want at the same time to make the design of the abutment and the secondary structure, you just choose design superstructure, you press next. Cement gap is the same as for the full anatomy crowns. We raise gapless area for 1.5 millimeters and 35 microns is cement gap. So here the program will do the secondary superstructure according to the form that we made the design. Right now we already pointed it will be not just full anatomy but full anatomy with cutback. So we can make, for example, just cutback of a buccal surface, or to turn it into the cap for the complete layering. We press next and we are getting this kind of cap that we can also smooth. If in the archive I would point out not full anatomy reduced, just full anatomy. So we don't have the step of cutback, but in this project we had full anatomy reduced. Initially we choose this option. We can smoothen it out, we can add and press next. That's it. We're going to the step of the screw retention, where the program will do the shaft itself, the screw access hole. So the shaft could be made with a slight increase, but will strengthen the edges, and during the milling there will be no cracks here. Or can we press off and it will switch off this protection edging, but I'll keep it switched on. Later we can, after the sintering or after the milling, we can just smooth it out gently. It takes 2 seconds, no more. We press next. So we are finishing the design of the full anatomy. You see beautiful shaft, beautiful seating area, beautiful housing, and here is abutment and a cap. For having opportunity not to have any problems with the fixation of the secondary superstructure on abutment with the immediate design, we can try to locate here abutment under the finish line and try to do this precise geometry during the design and milling, so we have very nice precise fitting of the crown. So it's ready.